A very good morning to the respected teaching community and all science lovers sitting in front of the screens at home. This is Govind Lakhotia welcoming you all to this 14th weekend science episode through our virtual platform of Bajaj Science Center. Last week, we listened to IIT Professor Chetan Solanki. And today is the turn to listen to an IISER professor who will explore the interesting and the most important aspect of the science related to definitions. Thus, I take this privilege to welcome Professor Pradeep Mohanty, who is serving as professor in the Department of Physics at IISER Kolkata. IISER, Indian Institute of Science Education and Research, which is there at Kolkata and which is there at Mohali, Thiruvananthapuram, Bhopal, even at more places. So this IISER Kolkata was established in 2006 by the Ministry of Human Resource Development, that is MHRD, which is now called as the Ministry of Education, Government of India. IISER Kolkata is an autonomous institution awarding its own degrees. The central theme of this institute is to integrate education with research so as we can generate more science people. So they club undergraduate teaching as well as doctoral and postdoctoral research programs. Professor Mohanty joined this institute last year in 2019. Before this, he served as professor in Saha Institute of Nuclear Physics, which is at Kolkata only. He served there for 14 years. Before serving there, he was the postdoctoral fellow at TIFR Mumbai, Israel, and even at Max Planck Institute, Germany in 2004. He did his PhD in 2000 from Harish Chandra Research Institute, which is again a prestigious national institute located in Allahabad. His research areas, listen it carefully, non-equilibrium phase transitions, self-organized criticality, non-equilibrium thermodynamics, exactly solvable models, network biology, microscopic modeling in biology. So these are not so easy to understand. I can say that he loves exploring biophysics and statistical physics. Apart from his core research, he takes a lot of interest in school science and mathematics education, because of which only he is here with us today. He has also contributed to Vigyan Pratibha modules developed by Homi Bhabha Center for Science Education, TIFR Mumbai. He is also a teacher trainer for Royal Society of Chemistry. Even he is also associated with Bajaj Science Center as a guest faculty for our Olympiad programs. Last year, he was here at Vardha in our summer school. With a great honor and respect, I invite Professor Mohanty to start this session and tell us the things about his cat. And you must have given the attention to the topic of this talk. So I invite Professor Mohanty for his talk. Sir, you can unmute yourself and you can start your session. Viewers, we need to wait for a minute. Sir is checking the settings. Something went wrong.
Okay. So am I audible now?
Yes, sir.
Okay. So first, let me thank to Dr. Lakhotia for giving me this opportunity, to speak about this. And firstly, let me say sorry for the delay and for the trouble. These are just some technical trouble at the end moment. So what I'll be talking today is about definitions. Okay, so the title is a bit catchy, like why cats are called as cats. So I'll go there. So firstly, you see, a cat is just a name, and naam mein kya rakha hai? Okay, like Shakespeare said in somewhere, like in Romeo and Juliet, like rose by any other name would smell as sweet. Okay, so नाम में कुछ नहीं रखा है, तो ये सब क्वेश्चन का क्या मतलब है, right? What exactly is the meaning of why do you call cats as a case? This looks like a very irrelevant question. You call cats. So what I'm going to talk today, and particularly cat has nothing special. There is nothing special about this sound called cat. It is different languages. It is also said very differently. Like it's in Odia, it's called Bilei, and there is also a scientific name called Felis catus, and there are many names. Okay, so cat is nothing special. So now, if you ask some other people, some set of people will come with a huge lot of information. Like cat is called cat because there is an English, it's an old English literature called cat, blah 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 blah, which I am not also interested. These are just a set of informations. How the word cat comes to us.
Sir, okay. Can you please switch on your camera so that we can see you?
Start my video. Is it okay? Is it okay now?
Yes, now we can see you. Please continue.
Okay. Okay, so cat is for me, as I said, that I'm not interested in the huge set of informations. What I'm interested here is the word cat, and it is just for me it is just a simple sound, cat. Okay, a simple sound which has meaning only if you know a language called English, right? And otherwise it is just a stray noise. It's not cat; it's just a stray noise. Okay. So language, if I want to see what language is for me, it is just representing or encoding complex descriptions using simple sounds. For example, if you want to say tree, right? I mean, the whole description, there is a branch and there is leaves, and all these descriptions together makes a very simple sound. You encode this whole description, big description, into a very simple word, and you call it cat. Okay, and there are very related words which are phonetically very similar: rate, mate, set, get, that, kite, kit, like that. But all these different sounds, they're very similar to cat, but they actually represent very, very different objects. Very, very different objects. Okay, so similar sounds do not necessarily codes different similar objects. They are very different. So the sound actually codes very different. And so what we do, when you look at your childhood, all you do is that whatever descriptions which you hear, what you sound, and all the descriptions, all the perceptions, and everything what you see around, you actually encode it with some sound. And later on, when you learn what you call education, is that the sounds are also given some symbols. So what you do eventually, by the time you are 7 years old, you actually create an inner world encrypted by sounds and symbols. Okay, so what exactly is perception, right? I mean, how do you see things or view things? So the word cat doesn't look like cat. If you say C-A-T, if you write, there is no way it has it also doesn't it doesn't look like cat, and it doesn't sound like cat. Right? I mean, the cat is not meow or something. Okay, but if you know the language and somebody whispers or somebody just speaks about this, you hear this sound called cat, you immediately in your brain, in your mind or inside, you imagine a picture of a cat. Okay, and that's the way you recover, you represent the whole description of cat, like how it looks like, how its eyes are and everything. And it is all this complex description is a simple word, and whenever you hear this word, you recall all the details of the descriptions and you represent it as a cat. Okay, so the language has this ability, and just with some combination of sounds, you can make your mother imagine the party at your friend's house. Okay, so you can just describe with some combination of words. Your mother knows the language, and she can make actually visualize how you enjoyed the party at your friend's house. So others, so basically, if you look at others perceive you through the sounds you make. Okay, so basically, if you're talking to others, other people are right. Who you are, that is partly represented by the sounds you make. So that is not it doesn't cost you much. So always speak sweet, because that's what other people know about you. That's the way other people perceive you. Okay, so language doesn't cover all sounds. So for example, any language you take, English or Odia or Hindi or any other Bengali or any other language, so it doesn't cover all possible sounds, because the kind of sounds the human voice can make is actually infinite in possibilities. Okay, for example, the sound of a drum, or intrigue melody of classical music, or the sound of a rain is not encoded directly in, you cannot make the sound of a rain just by making some words which you learned in childhood or any language. Okay, so basically the whispers of the mountain and all these things cannot cannot be described. Okay, so now okay, I don't know what happened now. Okay, now it is like a rainbow. Okay, so the sound, the continuity of the sound, like in all kind of sounds you make, is like a rainbow. Like the colors, the spectrum of colors you can see. So the visible spectrum starts at red and ends at violet. Okay, so this is a huge spectrum of colors you have. It's a continuous, all infinitely many colors, but you only know name of 7. Okay, so similarly, the sounds are infinity. You only pick up some simple sounds and actually encode some complex description into the sound, and that's the way you create the language. Okay, and the language has its own difficulties. Okay, for example, when you pick up these simple things, there is always a difficulty, and there is always something which is not encoded. For example, if you call animals, which has legs and this and that, and if you call birds, then you will be very confusing. What is a bat? Okay, so similarly, it's like you know the red, orange, but what color is this in the middle? Similarly, blue or violet. So what color is this in the middle? So these colors doesn't have a name, and it doesn't have a name in your in the language. So the other difficulty is that the cat itself is right. I mean, the word I started with cat, I go to language and description and sound. So if you look at cat, this is also a continuous spectrum. So basically, in evolution, cats were developed at some places like here, and and then they become some part what you call cats. They're cheetah, and then they become lion, and then the cougar, and then finally the house cat. Okay, so there is a continuous spectrum in between, and you do not know. For example, this particular picture, you do not know what the particular picture represent. Okay, sorry, this particular picture represent. So basically, there are exactly that the total the International Cat Association has organized like 71 breeds of cat, very many different kind of cats. So these difficulties apply to science too. Okay, so I will just explain what kind of difficulty, what is this difficulty. Okay, so let me just explain to you. Okay. This difficulty appears in science too. So let us say that, a finer description. So what I mean by science is that it's a finer description of reality, and I will try to explain you now what exactly we mean by science. So let us take an example of a example of dewdrops on grass. Okay. So if somebody see this, a dewdrop on grass, for some people, it's just useless. Like, there is no relevance to survival. It doesn't give you food or anything. So that just ignore. For some other people, it's just food for cow at home or the fuel for cooking. So they find it useful. For some other people, it is a poetry. So for example, Tagore has said that, I will not read this, but the poetry, it just means that I have spent money and covered a long distance to mountain and sea, but I have never seen the beauty of dewdrop on a blade of grass, which was just 2 steps away. Okay, so for some it is a poetry, and for some it is a painting. So this is a description of the same reality in many different forms. So for some it is useless, for some it is food or fuel, for some it is a poetry, for some it is a painting. Similarly, for science, it is much more details. We ask a lot of more questions. It's a vivid description, much finer descriptions which you want to take of this picture or this reality. So we kind of ask deeper questions like, why grass is green, or why water drops are spherical, why doesn't it fall, and why does it change color, and all kind of things we ask. Why it needs sunlight. So this is actually the right hand side. This picture, what you see here, is a picture of grass in micro scale, like, under the microscope. Okay, very, very low dimension, and this is a chlorophyll. So science, as you know, it's a language. It's a different kind of language. It's like, it's English, it's other languages. It's a more detailed description of things in different languages. But just because it is a language, it also suffers of the same difficulties language suffer. Okay, and that is the topic today. So what I mean, why do you call cats by cats? That what I mean is that, like, there is these definitions of things, and the definitions are not very rigid, and the definitions suffer from some difficulties. Okay, and these difficulties, definitions are necessary, otherwise you cannot speak. If you say that I don't want to define cat as a cat, I don't want this sound for cat, I want a different sound for cat, nobody can speak and nobody can understand. It's very useful and it's very much needed. The definitions are needed, but we should not be actually, right, it should not be going by the definition itself, because you should understand that definitions is not concrete. Okay, it is very fluid. That's my talk is, and I will give you 2 examples. First example 1 is the states of matter, and example 2 is geometry. And these 2 things you must have learned before, right? At class 10 or before. So now let us take states of matter. Okay, so in standard 3 and in 5, I think the states of matter has already been discussed. Like, there are 3 states of matter called solid, liquid, and gas. Okay, and but if you go a little higher, right, if you go higher classes, like 11, 12, you actually know that there are actually the solid is also, right, it's very regular arrangement of molecules or atoms, and similarly gas, there is no arrangement. Liquid has very little small arrangements here and there. It is packed, but there is no order in liquids. So if you go even further, like BSc, you actually say that the phases, like, or the states of matter, like, the state of the matter can change. For example, ice can melt. Ice is solid, it can melt, become a liquid, and water melt, become a liquid, which is water, and water can evaporate. Okay, so that's the way the state of matter can change. So now let us ask only one question. Okay, definition. Okay, what is the definition of a liquid, or what do you mean by liquid? Okay, of course you know. Think all the definitions. If you have heard up to class 10 or whatever, whichever level you are, just think of what is the definition of a liquid, and I'm trying to give some definition of what we know and a little more than what you know, and let us just qualify. So liquids flow, of course, like, I just take water and drink, so it flows to my mouth, and the liquid has no it has definite volume. So basically, if you take a 50, right, this kind of bottle and you put it somewhere else, it will still remain this 500 ml, right? If you measure it, doesn't matter how big it is, the volume of liquid remains same. But it doesn't have a definite shape that and it takes the shape of the container. There is a very interesting property of liquid which is called Archimedes law, which means the lighter objects float. Objects which are lighter than water, they float, and heavier ones sink, like iron sinks. Okay. There are other objects which you also know, like you can push your finger into a liquid very easily, which you cannot do in a solid. Okay. And if you touch a liquid, it will just give you ripples. If you disturb a liquid, it gives ripples. Okay. And these are the things which you already know. Something which you do not know, and maybe you have seen a beautiful picture of liquid and particularly water. So if you take a very small water drop and just put on water, it will show very beautiful structures. Okay. So this is okay. So this is called Reddington jet. Okay, so if you just put water, so they will just do this, and it will just like the water drop will come out and it will levitate. And this is one of the very beautiful picture, right? Beautiful form of water. People have seen it, and it is named after Reddington. Okay, so we'll go there. So these are the difficult. This is the definition of the liquid. Liquid flows. It doesn't have a shape. You can put your fingers, and now finger into the liquid. It has a volume, Archimedes law, and all kind of things. These are liquid. Now let us ask, what about sugars? Okay, so if you take sugar, for example, this one, and you can actually put it into a glass, right? You can do this. You know this. So sugar flows. Okay, it flows. What about shape? Actually, you can take sugar and put whichever in a bowl. It will look like that, and it has a definite volume also, right? That this is just because it is a definite volume. It has been used for measurement in old days. Like in Odia, it's called kotha. I don't know, there are pots, and one pot of rice is one pot of rice always, right? The weight of this is more or less same. You can push your fingers to a sugar bowl without any difficulty, without much difficulty, like in water. But what about other ones? Lighter objects float. So if you put a lighter object in sugar bowl, of course it will not float. And what about these questions? Let us ask this question a little seriously. And now, water versus sugar. So in water, if you look at intrinsically, there are small molecules in water and they actually move. But in sugar, the sugar ones, the drops, sugar drops or sugar crystals, they don't move. Okay. So to see the property of liquid, right? You have to make them move. Okay. Then you might see the same kind, whether you see same kind of behavior. Okay, so if you start, now already there is a difference. Sugar is a little different from liquid in that sense that you have to shake it, you have to put some energy. For the water, the energy is already available. So let us shake it, shake the sand bowl. Okay, so this is sand grain, and a ball is actually drop on the grain, and you can see that it creates ripples. Okay, a heavy ball on a sand creates ripple as good as ripples in water. Okay, so now go to the next one. In desert, so this is a man-made, but if you look at desert, so in the desert also you have the sand grains making these waves. If you want to see it again, you can see that the form of desert, what you call dungeons, they actually change, right? One place to other place. So the mountains, the same mountains actually move in the desert, one place to the other. Okay, so now we go to the Archimedes law. You are shaking things. These are heavy objects. They are going down. This is a light one. This ping pong ball. It just comes up. So lighter objects floats and heavier objects go down. This is like Archimedes law. Now this drop, does it make Reddington jets? Okay, it does. So this is a very, very regulated experiment. This is 11,000 frames per second. If you just hit a ball into sand, you can find these kind of jets like the water jets. Actually, just because the water jet is beautiful, just let me 10 seconds show you this video, right? You know, how the water actually looks like compared to this. Okay, I think it is very beautiful, right? This is the most, right? You know, just watch it. Okay. So I think the shapes and the way it happens in water and here they're kind of similar. Okay, the black and white, it's just because of some coloring. It's not nothing to do with, this is just a light effect, nothing serious. Okay, so what we find is that in all respect, the way we define liquid, okay, in all respect, sugar, just a bowl of sugar, satisfy all these properties in some sense. Okay, this directly these properties, and the other properties, if you shake, they can satisfy these properties. So now the question is, are the liquid? Rice, right? On plain rice, dhan or chawal, ये liquid है कि नहीं है? दाल और सरसों, ये सारे के solid है और liquid है. Now you are in a little bit of trouble because you have, right, why troubleshoot? Because you think that the definition I had for the liquid, I have properly understood, and I have a definition of solid, and I have a very clear picture in my mind what is a solid and what is a liquid. And this idea I'm breaking down in front of you. Okay. And to break this idea, you don't need a scientist or a big thinker to do that. It's all around you. You could have done it by yourself. Okay, you could have asked this question to someone, right? I mean, anyway, so we'll go further. So now, is it liquid? Okay, are these things liquid? So the general answer in science actually would say that yes, they are. Okay, at very high energy, even the cluster of galaxy will behave like a fluid. So this is when you look for the galaxies. Actually, people think of watery thing. When they want to do theory of galaxies, they actually think that these are water. Similarly, the impact of atom bomb can create ripples. And so it is, right, the whole earth can behave like a liquid if you put enough energy. Okay, so it all depends on energy. So we will come back to another state of matter called solids. So now you may think, right? You already know that you may think the definition of solid is unquestionable. Okay, liquid, I did something, but solid, I cannot challenge you. Okay, so they have solid has definite shape. So there is no question that a cricket ball and a golf ball, baseball, and an iron rod, iron bar, these are all solids. I cannot probably challenge you. That's what you might think. But let us see the videos. Okay, so now you might think that the cricket ball and golf ball and baseball and iron ball, all these would be solid. So let us look at the video. Okay. So this tells you that these are they change their shape. Okay. So the idea that you had that the solid has a definite shape is already broken down. Okay. So now what is a solid now? Okay. So if you ask too strictly, if you want to understand too strictly what exactly you define and how you are defining, there is no such strict definitions. Okay. There is no boundary in where solid ends and where liquid starts. So there is no strict boundary. Definitions are not strict. Okay. They are fluid-like. Okay. So now, this is what I say that, say in words. So if you want to prove, just to see this in numbers, you can think of the matter density. How much matter is there inside a solid and how much in a liquid? So for example, in aluminium, it is like 100, 2.7 or 2,700 kilograms per meter cube. If you take aluminium, if you brick, it is about 2,000 kilogram per meter cube. Okay, so similarly, iron is 7,000 800 kilogram per meter cube. Okay, so this is the weight. This is the kind of mass you have in iron. Okay, but if you look at gas, these are around. So if you look at liquid, these are around 1000 kilogram per meter cube. Very similar, but gas is 1 kilogram per meter cube. Okay, so basically you can see there is a lot of overlap in terms of the density. So now I go to my second example is on geometry. So what I'm trying to discuss is that the definitions are is not very rigid, and geometry is something in mathematics, and you might think that there at least I cannot question you. Okay, but that's not true, and I'll explain it with a story. So I was conducting a workshop with at Bajaj Science Center, and I think all the kids which I was doing this workshop, they're there. So this is a story about this class, which I taught. They're in class 8, I suppose, and so they did not know me, and but probably they had an idea that I'm giving a mathematics workshop for class 8. So in my first class, when I entered the class and I asked some volunteers, some student volunteers, asked them, okay, come on kids, draw something on the board. Okay, so most kids came and they drew objects which are very regular, like, they do circle, triangle, square, and cylinder, and somebody draw a home or some such thing. So these are very simple objects people draw. Probably they had an idea that I'm going to teach math or geometry or something, so they did that. But I was actually thinking of teaching something else, like irrational numbers. So, but anyway, so they started like that. But one of the guy, I would not name it, let us call him Chiku. Okay, so Chiku drew the following. He just came and just rolled the chalk on the board. Okay, and they're kind of pretty smart, and I am very friendly, and probably, and they came and just draw something, and then I did not know what to do. Right? I mean, then I didn't know how exactly to proceed in the class next. So what I did is that I actually changed the discussion. I had a pre-decided thought, and then I changed the discussion. I asked them to redraw the same again. So I asked the one who draw a triangle. I asked him to draw a triangle nearby in the neighborhood of the blackboard. Okay. So he could draw. The other guy who drew a circle, she also came and could draw a circle there. But this guy, Chiku, he could not draw the one which you drew. Okay, he tried repeatedly. I said that, okay, erase it, draw it again. He could not just do it. He could not do it in 3, 4, 5, 7 times. He just could not do it, and the class was laughing like anything. And he was thinking that he's punished for that. But then I just say take this opportunity and tell that this is what we call complexity. Okay, complexity. So when you cannot grasp all its features to describe or reproduce, even if it is in front of you. Okay, so if something is in front of you, you are watching this, you are perceiving this, but you cannot reproduce it because you cannot reproduce it because the language what you have is not enough to make a description of what you see. You just get a gross description of what you see in front of you. Okay, you just say that cats and dogs, you don't actually distinguish 71 breeds of cats. Okay, you just say red and blue and green, and you don't know these intermediate colors. So that language, your perception, is only some partial thing, and you cannot really grasp the complexity, and this is called complexity. Then I ask a question that how does nature look like? Anything you look around, whatever you look around, not man-made things, whatever nature has created all around us, the grass and the trees and all around us, whatever you see. So how do they look like? Do they look like circles, triangles, hexagons, polygons, or does it look like what Chiku drew? Okay. So most people actually agree that the nature rather look like what Chiku drew. So the nature in principle is complex. Okay. So they gave me a lot of examples of natural things. So then I ask a question: what's the point of studying then this circle, triangle, hexagon, polygon? What do they use? Why are you studying this then? Okay, because they don't have a utility. The nature doesn't look like that. It's just useless. There is no utility. Why should you study even those? They got a little shocked, and after some time, they actually come up with the answer by themselves, saying that, well, the complex objects are made of simple components. Because anything, if you go very finer one, you can actually find a straight line everywhere, okay? Or maybe there is an angle somewhere, there is a straight line somewhere, there is a small curved line somewhere, okay? Simple objects are made of, complex objects are made of simple components, okay? So for example, I just give you an example. This is a picture from a computer, called, I don't know, this operating system, Ubuntu. So this is the logo. So you can see that this is simply looks like a cat. But if you look at it very carefully, each part, each line is part of a circle. I just wanted to show you this, that each part line is a part of a circle. So first I draw some circles, some lines are covered, and then another set of circles, some other lines are covered, and I take another circle, some other lines are covered, and then more circles, and I cover the whole cat. You just see circles, no cats, which means the cat was actually made of a partial part of circles each place. You can see actually see the circles. So this is what you mean by a complex object is actually has small components. So now, what are the simple components for planar drawing? That's the next question for them. Okay, so they actually come up with the simple components of a two-dimensional drawing. Whatever drew on the board, it just point, straight line, angle, circle, like that. And then I ask, what is a point? And then one of them, he remember what is the definition of a point. Definition, remember the word definition. So it is a point, is a zero-dimensional object having no size, there is no width, this, that, with no width, no length, and no depth. I said that, oh, okay, right, these are all you study, but do you know what is a point? Can you draw it, for example? Come here and draw it. So the guy came and drew a point on the blackboard. Then I asked the class, this is the same guy who drew this complex thing, right? So then I asked the class, do you agree that this is a point? The class somehow did not like him that day, maybe. The class says that, okay, that's not a point. Is this a point? That's what I asked. The whole class says, no, it is too big. Why it is not a point? Because it's too big. Then I asked, okay, the guy said too big, the girl, she came and I said that, okay, draw another point here. What do you think is a point? So she drew very minutely, very small dot, and they said that this is a point. And then the whole class actually unanimously agree that this is a point. Then I asked another guy and then said that, you just bring your pen and notebook and draw a point there. And he drew a point. Then I ask, is this a point? And the whole class says that, yeah, a little confused, but they said that, oh, okay, this is also a point. This is a point too. But then I said that, this point, which is on a notebook, is smaller. The blackboard is bigger, but you agreed already that the blackboard is a point. So which one is a point? Is it a point? Is it not a point? So now they're all confused. And by this time, probably you are also confused. Okay, many of you are also confused. What exactly is a point? So what is a point then? Okay, so if you want to understand this, the point is actually a mathematical construct. It's like a language construct in your mind, in your brain. It's a mathematical construct. The point itself doesn't exist. Okay, a point is shown by a dot. So a dot is only a representation of point. It is not the point itself. Point is an idea, and what you draw on your blackboard, on your notebook, is a representation of that. It is shown by a point. You are representing that idea. So it's like a drawing of a cat is not a cat itself. It's like CAT if you write, that's not a cat itself. It's a representation of a cat. When you look at these kind of symbols, you think of a cat. That's the meaning. Okay. So similarly, if you go to straight line, there is no way to know something is straight unless you already know something else is straight. Because to know something is straight, you have to measure it, right? Unless you know that the measurement instrument is straight, you cannot measure it. So it's just a circular argument. There is nothing called straight. And similarly, all geometrical objects are mathematical construct. There is nothing, no circle is a perfect circle. You don't see it anywhere. Okay. So the one which you like, maybe the moon looks like a circle, but that is only from a distance. If you go zoom it, it's not a circle anyway. Okay, the one you draw on the board is only a representation. So what we learn here is the description of reality. Okay, so you have a circle or you have a cat, and its description when you are describing by writing it or by pronouncing it. Okay, so the description of the reality is not the reality itself. That's the point I want to make. Okay. 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 So what are you doing here is that like a kids, like, you know, if you look at how we were living and how we are doing our day jobs and things like that, is that you know, we're living in this world, and the world is full of things, matter or energy. It's just full of things, and all, like a kid, we are just partitioning them. Like, you know, if you give the kid, like, you know, this whole set of objects, somebody can partition into sports and food and dresses and you know, animals and tree and plants and vegetable fruits and fruits and vegetables, like that. So somebody can just partition like that. Some other kid is partitioning like green, red, orange, pink, like that. So he just takes all green object one place, other place, like that. Okay. And like adults, so this is some kid, this is another kid, and like adults, what we do is that we actually partitioning the objects like his, her, theirs, others, and mine. Mine is a big portion, of course, and that's the way we are partitioning the things around us. So large part of self is conventional definitions. So, right, I mean, you know, these definitions, when you call up definitions, it actually, you know, if you think very hard, actually it is really ask questions on yourself. What you call self is probably is also a set of conventional definitions. And you are, in the definitions, the boundary should be fluid. It should not be very rigid. If you leave very rigid with the definitions, you actually leave very little, because you don't have an option to see a lot of things, and you deny seeing things. Okay, and that's what happens to most of us. So in a science too, we divide this, like, you know, in universe, we call it science. We define math, which is just a pool, and physics and medicine and biology and psychology and chemistry and things like that. Okay, so we keep partitioning things, and it is not that it's not a useless partition, right? I mean, you know, if you say the whole universe I want to see by myself, it is not possible. As a physicist, I have a certain portion I understand, certain aspect of the universe I understand, and a medicine or biologist, she understands something else, some different part, and a chemist, he understands something very different, and psychologists understand this a little differently. It's the world, and it is all our responsibility and our job to understand different parts, so that you can get some utility out of it at some point, maybe. Okay, so that's the way it goes. Okay, so now I think I come back to the colors again. Okay, the colors which I talked about, I come back to the colors again. Okay, so now this bright yellow color, which you see in a marigold, genda phool or monda phool. So the bright colors which you see is not the same yellow what you see in your garden, by the way. Okay, why? Because when you see it in the garden, the colors is only a reflection of certain wavelength of light, okay, which is near close to yellow. Okay, but when you digitalize it, when you take a picture, a digital color is only a mixture. If you know colors, a digital color is always a mixture of 256 shades of red, 256 shades of green, and 256 shades of blue. Okay, so the red, green, and blue, they mix together to give you an idea of something called yellow. Yellow is a color which doesn't exist, and even if it exists, right, I mean, you can mix something to make a yellow. So in total there are, right, 1,67 lakh 77,266 colors. This times that 256 whole cube. So 2 to the power 24. Okay, that many colors are there. There are many different colors computer can produce. This is the total number. There are many, but they're not all. Okay, so chances that the color of marigold is exactly one of these colors is very low. That what light reflect, what kind of wavelength is reflected from a marigold, is chances that it is one of the color is very low. It's like, if you go to a market and you are buying something and the price, so like, you also partition the money, right? I mean, the money, you said that, 1 rupee 35 paisa, you are happy. After that 3507, those you don't bother about. So the chances that, somewhere in a supermarket, when you are buying, the price will be exactly 1 rupee is very low. or exactly 375.00 rupees will be very low, because there are taxes and everything and all kind of calculation will add up, and there will be some numbers which will not be different. So similarly, the light which is reflected from the marigold is some number. It doesn't have to be one of these. Okay, so what you are seeing or what you are perceiving as yellow, the description of reality, again, just to say that it's not the reality itself. Okay, so with this, I'll go to the summary. So what we talk today is that definitions are useful for classification. Okay, it is necessary for, the definitions are also necessary for communication and understanding, because without the definitions, if I would not say cat is a cat, I मेरा अपना मर्जी में कुछ भी बोलूं, so then the other people will not understand what I'm saying. Okay, so basically I have to accept the definitions for its usefulness. Okay, it's understanding, and for communication and understanding, it is very much essential. It's also necessary in science, the way we define force and the way we define temperature, if you right, and all such things. Okay, but we must understand the limitations also, because the limitations are the one which, if you understand the limitations, then only you can go beyond. Okay, so what I'm saying that if definitions bother you, by the way, right, most people are quite satisfied with the definitions. The definition of solid, definition of liquid, definition of what is hard property, and definition of what is me, and definition of what is light, and most people are happy about the definitions which are floating around, and they are satisfied. If it doesn't satisfy you and if it bothers you, it is good for you. Okay, the confusion takes you beyond the definitions, and it leads you towards a better understanding, by the way. So I stop here, and I acknowledge particularly YouTube for the videos which I collect, a lot of videos which I collect from YouTube particularly, and curated them to my need. And I also thank Google for everything. And of course, Bajaj Science Center and Dr. Lakutia for giving me this opportunity. And I stop here. Okay.
Okay, well, thank you very much, Pradeep sir. Could you please switch on your video? Viewers want to see you.
Okay.
Well,
yeah.
Thank you very much for this wonderful session. After struggling for the connections and all, you have covered the points very nicely. So from your session, I could collect one sentence for you. So you have covered all important point with a proper point so as to hit the point, and the point is now to point out the questions from your session.
Thank you.
For this, I would like to invite students in our Zoom room, and details of our Zoom room I am sharing on my screen. The students who are following us on the YouTube can join the Zoom room with this credential. So you can note down this Zoom meeting ID and password, and you can join Zoom room if you have any questions, so that you can talk to Dr. Mohanty directly. So our ID is 859-1889-7385, and passcode of Zoom room is BSCWST14. Please enter the room with your name only. I will permit the person with names only. So with this, I will stop YouTube sharing, and officially I am thanking you for your time, for giving your important time to our kids. Thank you very much, Pradeep sir.
Okay. Yeah.
So we'll take 2 minutes break, and then we'll join back in our Zoom room.